Good evening, all. So I think day after tomorrow we are writing Uceed exam. Okay, so maybe tensed. I think there is no need to be that much tense to write this particular exam because this exam is not based on the by heart and contents. Okay, it is purely based on our common sense and those who are following our sessions. Okay, earlier, that means our video sessions throughout this channel earlier had already developed some sort of common sense which is required for this particular exam. So being on the 2 days before the exam, I think on Friday here. Okay, Friday. So Saturday and Sunday, one more day is completely with you guys for revision, not for learning anything new. Okay, just it's for simply for the revision. And what you guys record for the next 2 days is a good sleep. Okay, today, tomorrow, and Friday night, Saturday night, Sunday night, that depends upon you. Okay, anyway, both you better to have a good sleep. Okay, that is my suggestion. Because I mentioned earlier, this exam is purely based on our common sense. So for these senses to work properly, good sleep is essential. And I just come up with few questions. Few questions means a few common senses which record for solving question. So I will mention that common sense, what is in that question, and questions based on these common sense has been regularly in this exam also. So better having an idea about these things. A few things I will mention, and if you find time, you can Google some terms which I am going to mention in this class. Okay, including I think last year in 2023 or 2022, there was a question during COVID times. There was a question directly connected to Fibonacci series. Okay, so Fibonacci series is a set. Okay, it's a set of common senses available in that. So inside the Fibonacci series, it is written inside a Pascal's triangle. You can Google it in the Wikipedia. You can find Pascal's triangle. Inside Pascal triangle, you can find triangular numbers and tetrahedral numbers and so on. Those numbers you can find, their physical meaning you can find. All these things are common senses which should collect to write this particular exam. Okay, anyway, I'm just directly getting into some questions. Let me share my screen just a second. I hope my screen is now shared to all. So we have similar sessions for NIFT also in the coming weeks. So anyway, those who haven't subscribed our channel, they can subscribe it now. So now we have a question, and these questions are sourced from our own material. I had to some previous questions also along with this. So this is from our book 360. Okay, for the 360 for the logic. That means that is why some watermarks are there. That is our own watermark. So this is sourced from our own in-house material. Okay, so this is what our repeaters batch and all those batches are using. This printer version is available with them. So now we can solve this question. A pegboard. Okay, a pegboard shown below has a rubber band stretched around for red pegs. Okay, see, you can solve this question now. Similar type of question has been came in this exam earlier. Okay, similar case means similar logic. Okay, similar logic. I will, for those who had seen the previous question papers, I can take you to that question. There was a question when 3 circles were connected by like this, centers are connected by this. Area of that triangle is 3.14. Okay, I'm talking about an earlier question. And what will be the area? I'm not drawing the complete figure. I'm just trying to recollect it. Okay, so what will be the area if it was a triangle like this? Okay, there was a question. Okay, those who gone through the previous year question can easily recollect this. Others leave it, no issue. Okay. So in these later hours, there is no need to visit that question. Okay. So if you have time, and if you wish, you can visit that. Unless there is no need to have. Anyway, we can solve this question. So there, in that particular question, when I was discussing that, even in YouTube also, I was constructing a parallelogram. I just constructed a parallelogram out of that, and I just connected it, and I took the area of half of the parallelogram, okay, through the diagonal. Similarly, diagonal, the same concept, but in a different way. See, we want the area inside this or enclosed in this rubber band. See, how many units? You can put it in the chat. Let me check your responses first. Okay, just a second. I'm looking for your YouTube responses. I want all of you to solve this, okay? Because consider these things also like a mock exam. No replace. It's your time. For the annotated copies of this particular one, you can message the number which is showing in the chat box. So now in this question, now we can solve. So over here, I'm just dividing this figure into different portions. See, easily we can figure out these three because they are completely here. Other rectangles are partial. So now we are looking into those partial rectangles. Okay, see, already it is having 2 units. And diagonal is dividing that figure into 2. So inside our question, only 1 unit will be coming because total 2 and half of that is 1. Okay, so 1 unit over here, 3 units you can find here. Okay, inside this figure, you can find 3 units altogether. 1, 2, 3 I had marked. And over here, when you come over here, total 4 units. Okay, out of this much is outside this, but out of the 4, half of that, total it is 4, half of that will be 2. So 2 is inside our figure. Now the final area, this is our final area. This much portion is outside, but half of that, that is out of the 3, 1.5 is still inside. So now you can add 1.5, 1, 2, 4. So now this is, sorry. And this is 3. 1.5, 1. This is 2 and that 3. So 3 plus 2, 5. 5 plus 2, 7. 7.5 is the right answer. Okay, 7.5. Now we can try another question. So we are going to learn a new equation over here. See, here is a condition. How many triangles can you draw from the vertices of a heptagon? Vertices of a heptagon that don't possess sides that are also sides of the heptagon. Okay, that don't possess sides that are also sides of the heptagon. Okay, see, we can't draw it in a square. We can't draw it in a pentagon. Okay, but we can draw it in a hexagon like this. So here, no sides of the polygon is the side of that triangle. So hexagon only can provide 2 such triangles. How many such triangles can be provided by the heptagon? See, this is definitely a time-consuming question, and you will end up drawing plenty of figures. Okay, because we have an intuition that we can definitely solve this question. So we will try to draw the figures. Once we started drawing, when we reach the 4, we identify that few more are still there. We should draw that. So anyway, for drawing that 4 figures, you will be ending up with 1 minute. And 2-3 minutes you will be taking for the remainder because you need to think a lot to draw. So there is a formula. Okay, there is a formula. So for the formula, it will be like this. Number of triangles of this particular type. Number of triangles of this particular type. Let me make some editings over here. I will do it in the final. Okay, last I will be doing that. So over here, it will be like n into n minus 4 into n minus 5 divided by 6. Okay, n into n minus 4 into n minus 5 divided by 6. Okay, so now comes to this hexagon problem. So hexagon, we only get 2. Let's see how that 2 is coming using hexagon. See, if I write a formula, there is no need to blindly follow it. No, hello. Okay, so over here, just substitute 6 here. 6 into 6 minus 4 into 6 minus 5 by 6. Okay, 6 into 6 minus 4 into 6 minus 5 divided by 6. So this is 1, this is 2, this is cancelled. So 2 into 1, we are getting 2. That 2 is here. So this is our golden formula. Okay, this is our formula, what we record. So this 6 is a constant, okay. This 6 is a constant, and that is not for the hexagon. For every shape, that 6 is a constant. It will not change. It will be definitely a constant. Now comes to the heptagon. See, guys, you guys can solve it now. Now just comes to the heptagon. So heptagon, that will be like 7 into 7 minus 4, that is 3. 7 minus 5, that is 2, divided by 6. 3 into 2, 6. 6 and 6 cancel. So you can construct 7. For the question, the answer will be 7. Now try this question. Okay, now try this question. So in the meantime, I will make the corrections for this. I can give you an equation. So instead of heptagon, just simply write a polygon. So I'm just simply removing the heptagon, and I will write a polygon over there. I'm talking about regular polygon. Then you can depend upon this equation. Okay, so you guys can take a screenshot. Aditya, what if we consider the sides? Simply go for NC. This is triangle NC3. Simply go for NC3. Okay, this is from permutations and combination. NC3 will do that. Okay, if you need to, for a polygon like this. So actually this is applicable from pentagon onwards. Sorry, pentagon onwards it is working. So you can go for 5C3. Okay. So now in this question, n into n minus 4 into n minus 5 by 6. Applying over here. How many sides? It is octagon. 8 into 8 minus 4 into 8 minus 5 divided by 6 again. So 8 minus 4 is 4. 8 minus 5 is 3. So 4 into 3, that is 2. Sorry, 4 into 3, it's 12. 12 divided by 6, that is 2. So 8 into 2, 16 is the right answer. If you go for drawing, you will end up wasting 15 minutes for drawing these. Okay, if you have this technique in mind, the Uceed is yours. Okay, so Arnav and Nerdron. Okay, actually, I'm not good in reading names. Okay. Next question. Another one. So now you guys can try this question. Examine the complex polygonal map illustrated below. Then count the number of points represented by the black dots. These points, black dots, we called as vertices. Okay, from that number, subtract the number of sides. Sides means edges. And add to the result to the number of regions. regions is the faces or surface. Okay. See, actually, we are discussing about, see, this particular things. If you find this is about Euler's formula of polyhedra. Okay, we are talking about a very famous formula, and this is the common sense. This is a common sense, and this particular common sense. See, the name of the common sense is Euler's formula. Okay, even common sense is having its own name. Okay, see, these things are called common senses. Okay, so over here, we need to use Euler's formula of polyhedra, and several times in different manners that particular thing has been came in the question paper. So now we can solve that. So Euler's formula is like this. Faces plus vertices will be equal to edges plus 2. Okay, what is the demand of the question? Let's look into the... Actually, I'm not counting this because there is no need. Okay, because they are talking about a universal thing, which is a common sense. Okay, so over here in this question, count the number of points represented by the black dots, vertices. Okay, and subtract the number of edges and add to the result number of regions. Okay, this is what actually, this is the rearrangement of this. E comes here only, so the answer will be 2. Why should we waste counting all these things? That is the question. Okay, if a student is aware about this particular one, his numerical answer 2 will be in that box at the right time. And you can, if you read this question, assume you took 30 seconds to read this question. Okay, assume 30 seconds to read this question. Nobody takes 30 seconds. Even I'm giving 30 seconds. For marking this 2, you record 2 seconds maximum. So this question is solved in 32 seconds. This question is solved in 32 seconds. And the time which you saved in over here can be utilized for many other questions. Why should you read all these things if you have the right common sense? Okay, so play with common sense. So now let's try another one. See, another important arithmetical logical concept what we are going to learn. Okay. Now, in how many different ways, ignoring rotations, can 8 family members see themselves around an octagonal dinner table? See, actually, this is circular permutation. Now you can see over here, this is A. Okay, nobody, maybe somebody over here doesn't know permutation. It's not a matter for solving these questions. Just learn what I am giving over here. Okay, that's enough. So over here, A, B, C, D. See, we can write A, B, C, D like this. And we can write A, D, C, B. See, I'm writing clockwise first. Next, I'm writing anti-clockwise. A, D, C, B. Okay. Actually, these two are same. Okay. Actually, these two are same. But when they are same, if we consider rotation, then we find that that is a clockwise and anti-clockwise. If we consider rotation, if you are not considering rotation, ABCD will be ABCD and ADCB will be ADCB. Okay, so there is an equation of circular permutation. If there is n objects, then those n objects can be permuted in n minus 1 factorial ways. So over here, there is 4 material. So they can be done in 4 minus 1 factorial, that is 3 factorial ways. Okay, see, this is ignoring rotations. Okay, So we are talking about the case of ignoring rotations. If you start to consider rotation, ABCD and ADCB is only one. They are exactly same. Okay. If you are not considering rotation, ABCD is something else, ADCB is something else. So we are not considering rotation. So we don't know which is clockwise or which is anti-clockwise. But if we start considering rotation, at that moment, we will figure it out. Oh, one is just a copy. It is clockwise and anti-clockwise only. So consider only one. Okay. So instead of 2, we will took it like 1. At that time, okay, this is ignoring rotations. And when considering rotations, when you start to consider rotation, you know that one is clockwise and the other is anti-clockwise. So for that time, the circular permutation will be like n-1 factorial divided by 2. Because we had already taken 2, divide with the 2, you will get the right one. Okay, so these are the formulas. You can take a screenshot. Now comes over here. Here, some people are sitting around an octagon and he's talking about circular permutation. What is the sense over here? See, this is also a circle. Imagine like that. Okay. See, shape of the table is not the matter. They are sitting. Okay, they are sitting like in a circle. So that is the matter. And 8 peoples, 8 minus 1 factorial, 7 factorial, 7 factorial. What is 7 factorial? 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay. So if you have this right technique with you at the right moment, then 5040 will be coming into your answer sheet within a minute. Why? For what purpose the time is taking? Time is taking for taking the multiplication, nothing else. If you are too quick at the multiplication, answer will be here without any that much delay. Okay, and fine, good. So let's try this question. How many different diadems? See, consider it like a ring, which is wearing in the head, like a crown. Okay, thing like that. So here, can you make using 7 different precious stones? So over here, clockwise and anti-clockwise things are considered. Okay, you need to consider what? Rotation, because anti-clockwise and clockwise design will look the same. So at that time, what will happen? King will cut your head. You try to cheat the king. Okay, so over here, 7 minus 1 factorial. Okay, 7 stones. Okay, if you are ignoring rotations, it will be 7 minus 1 factorial. If you start to consider rotation, 7 minus 1 factorial divided by 2. That is 6 factorial divided by 2. What is 6 factorial? 720 divided by 2. 360 it is. Okay, 360. See, we just learned in the previous page. Okay, the same. So let's move to the next. These 2 regular polygons. Okay, another important thing which the examiner like is equilateral triangle. Okay, you see it like the equilateral. That's fine, good. Equilateral triangle is a thing which is liked by examiner very much, especially you see. Why? Because as my knowledge, when I go through every question paper, I should use this particular equation. Okay, area of an equilateral triangle, √3/4 a square. Every question paper is having a demand of using this equation. Okay, according to Uceed, they don't have nothing. Okay, they don't have anything important like this. They every year they will ask a question beyond with this question with this equation, and for this year also I'm expecting. Okay, I'm not talking with a question paper in my hand. Next day, if you find this equation in a question paper and you claim that Sir predicted it and it comes. So all the media will comes to my home. Okay. Don't do like that. This is just going through the previous year question paper. I find this equation every year coming. Okay. So that's it. Only that much relation. I'm not printing these question papers. So I'm expecting this time also this. And 99.99% sure it will be there. A question solvable through this equation. Okay. If there is question from area volume chapter, minimum 5 questions are coming in this chapter. If 5 questions are there, one question will be based on this. Now you guys can solve this question. Sorry, I'm not well. Okay. Anyway, come to this question. These two regular polygons, a regular hexagon and an equilateral triangle have equal perimeters. What is the ratio of their areas? So assume every side is A. Okay. For the sake of doing this question, I'm just dividing that figure into parts. So perimeter of this figure equals 6A. I'm right. So this one also should have a perimeter equal to 6A. For that purpose, every side should be 2A. Okay. Every side should be 2A. So first of all, we can find area of hexagon. Actually, I don't know the equation for finding the area of hexagon. Okay. I don't know means I'm not remembering the equation. Why? Because there is no need to remember that equation. Because whenever I found a hexagon, I will divide the hexagon into equilateral triangle. How many equilateral triangle? 6 equilateral triangle. Okay, this is how I remember the equation. Okay. Aditya. Okay. Okay. Now he is having another equation. It's in a square seem to be difficult for me even. Okay, we have simple equations. Okay, don't make it complex using cot, tan, all those things. If you have it, then fight. Okay, anyway, now comes to this particular one. Area of equilateral triangle. What is the area of equilateral triangle provided over here? Root 3 by 4. Instead of A, we have 2A square. So it is like root 3 by 4, 2 square 4, A square A. So now read the question. Hexagon first. Area of hexagon to area of equilateral triangle. So area of hexagon by area of hexagon by area of equilateral triangle. Area of hexagon 4 into root 3 by 4 A square. I took the 4 to the front. Next is 6 into root 3 by 4 A square. Okay. Cancel, 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 cancel. 2, 3. So area of hexagon to area of equilateral triangle. Finding the answer is not the main thing. Reading the question. Okay. Aditya, clear? 2:3. Okay. Oh, sorry. My fault. Aditya is right because I just changed the places. This is 6. This is 4. Now Aditya is right. My bad. Okay. 3:2. He is right. Okay. So reading the question is important and writing the numbers more important. So 3:2. That's it. That's it. So let's try the next question. See, actually, there was a question, as I mentioned earlier. There was a question. See, every question which I'm discussing is having a pre-connection of a previous year question. Okay. Previous questions connected, new questions I'm asking. And I just try to ask the logic next to the question. Okay. See, if a question comes, Fibonacci series is coming. If a question earlier, question from Fibonacci series was coming. Yes, Abhinav, I am teaching live, but he will reach here after a few minutes. Okay, so in Fibonacci series, a plenty of things you need to learn. Pascal's triangle. Okay, Pascal's triangle. Fibonacci series once in a question paper. Okay, once or twice the concepts were I think 1 or 2 times the concept has been asked. So Pascal's triangle is another concept, and triangular numbers another concept. So if you learn triangular numbers, square numbers, tetrahedral numbers, okay, hexagonal numbers, different things are there to learn. Okay, so pyramidal numbers. So you can refer all those things simply by Googling. So I'm not going to ask a direct question from Fibonacci. I'm using triangular series. Okay, so can you work out how many objects there are in the 18th triangular number? 18th triangular number. Okay. Okay, so if the question comes, they will not give this much story and they will not tell you triangular number. Even that word won't be there. But they will come with these beautiful figures. Okay, they will come with this beautiful figure. So over here, this is only 1. This is 1, 2. So total 3. See, actually, triangular number 1 means 1. Triangular number 2 means 3. See, this is triangular number 2. So this is triangular number 3 means 1 plus 2 plus 3, 6. Triangular number 4 means the value of triangular number 4 is actually 10. 1, 2, 3, 4. So triangular number 5 is 15. Actually, these are sum of what? Sum of natural numbers. And in the 10th grade, we learned an equation. Sum of n numbers, 1 plus 2 plus etc. up to n. Sum of n equal to n into n plus 1 by 2. Okay, n into n plus 1 by 2. That means it is equal to n instead of n, you can put 18 because we want up to 18. 18 into 19, that is 18 plus 1 by 2. So 18 and 2 cancel, that is 9 into 19. Okay, so this is 171. Yeah, this is happy. Arithmetic progression, first chapter, grade 10. Okay, so 171 is the right answer. So similarly, we can solve questions. This is a old Uceed question. Why I am introducing that question over here in the last moment, I need to talk to you about Eulerian trials. Okay, another important thing, you can Google the word Eulerian trial. Okay, so that is a technique without lifting hand. See, the issue of this question, every student tried to draw without lifting hand in the exam hall, and those will end up at losing a lot of time. We have a technique. See, that is a odd junction rule. Odd junction. If the number of odd junction is 0 or 2, number of odd junctions are 0 or 2, then we cannot construct this particular one. Okay. So if the odd junctions are 0 or 2, okay, see, okay, over here. Now we can just take an example. So over here, this is even junction. Okay, this is even junction. This is even junction. No issue. This is an even junction. Okay, because only 2 things are coming to that. 1, 2. All these things are even junction. So we can construct this. Option A. Coming to option B. These are even junction. See, this junction, 4 lines are coming. So these junctions are called even junction. Okay. See, option B is also constructible. Now comes to option C. 1, 2, 3. Okay. Odd junction number 1. So if it is 0, we can construct. If it is 2, we can construct. Any other number, we can't. Okay, n number of even junction you can have, but odd junction, it should be 0 or 2. Then only we can construct. Now it is 1. This is 2. See, 1, 2, 3. Now this is 3. Now this is 4. So now the number of odd junction is more than 2. Okay, so we can't construct option C. Now comes to D. Even, 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 even. Everywhere it is even, no odd junction. Okay, that means odd is 0. So odd equal to 0. So we can construct. So we can take a screenshot of this also. Okay, take a screenshot. Okay, clear. So this will be the last question which we are going to discuss today. So I'm not going to discuss this question completely because several times I had discussed the same in YouTube. So the answer for this question is 72. And what I suggest is these are symmetrical figures. Okay, so you can save time by counting only one side, and this is a depression. Okay, so you can together count 5. This is 5, this is another 5, 10. Okay, just start with 11 only, 11, 12. In this way you should count. So how it is 5? One here, second one here, third one not clearly seen, but you can find here. Fourth one not clearly seen, but you can find here. Okay, and this is the fifth one, the ground itself, the depression. Okay, so 5 here, 5 here, 5 plus 5, 10. And you can count the surroundings. You will be reaching it like 20. So if here it is 20, here also it will be 20. So when you count over here, this is 5, another 5, 10, and this is 11, 12, 13, 14, 15. So this portion is 15. Then this portion is also 15. Okay, we can save time. 20, 20, 15, 15. And now it is 70. Top 71, bottom 72. Okay, so this is the quickest way of solving this question. Last year, many students stick on this question and they ended up at solving it wrong also. Wasted a lot of time. That is why I included here. Okay, so for the annotated copies of this particular one, you can contact in the number provided in the chat, and we will be starting our free NIFT B.Des online mock test as well as NIFT accelerate batch. Okay, 10 online sessions and 2 mock tests will be there. So it will be commencing from 27th January. Interested people can contact in this number. Okay, thank you all. Wish you all